In addition, MicroPython has a support for a feature that I really like, which is you can type your attributes in the init method, okay, and it will remember those types and complain if you attempt to assign to an attribute with the wrong type. I view this as a really good thing because that's the other big problem I've had, which is they're assigning to a class and transposing two characters on an attribute name, and Python's perfectly happy to do that, and it takes a long time to find that transposition. And with this, it says, I don't know what you're doing. You've already defined the values that can go into your class. So anyhow, so that's the next thing. So let's do a definition of a function. So you go def, function name, argument, colon type, comma, dot, 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 argument n, colon type n. And then they use this hyphen greater than syntax for the return type. And you can have multiple return types after that, okay? And then you have to have the following colon. And I have an extra quote in there that's bogus, so there's no quote after that ret type, okay? If you want to just define a variable that's going to take a particular type, you just give variable name colon type. You're only allowed to define the type of a variable once in a function or a method. Okay, and MicroPython will complain vociferously if you attempt to define it more than once, even if it's the same type. It just sits there and says no go. First definition, first one I see is that's the one I'm taking. You can also define the type and assign an expression at the same time. And then if you're doing unpacking of tuples or something like that, you would like to do what I say with left colon int, comma, right colon int. No, not allowed. They don't support it. Okay. Instead, you have to declare the variable separately on separate lines. Okay. And then lastly, Python uses classes. You need to sort of tell MicroPython that your variable really is a subclass of something. You use assert isInstance subclass variable to sort of force MicroPython into knowing that it really is a subclass rather than a superclass. And this is just it's a MicroPython, and you just have to learn how to, whenever you need to do this is what you do, because otherwise you just can't write the code. It won't work. Okay. So I'm going to do a very short type hinting example here. This is the perennial factorial program, which is, nobody really writes factorial programs this way, but it teaches recursion. So I'm going to import the list from typing. We won't go over the stupid factorial function because there's nothing interesting there. But you see it takes n as an int and returns an int. And then we have the main function, which doesn't return anything. And I define a variable n. And then I'm going to create a list of factorials. And I define that the list is going to be a list of ints. And then I do a Python list comprehension, which I'm still a little uncomfortable with list comprehensions, but I decided to do one here. And it computes 10 factorials from 0 to 9. Okay, and then I can print them all out using a for loop. And again, you see that I can't put the variable declaration for n factorial in the for loop. I have to define it in front of it. So it's a little ugly, folks. But again, you get used to it. Okay. And you'll see down there in that print statement, I'm using a formatted string to print out the values. So, okay, I just wanted to tell you that type hinting is there. It's worth looking into. It will help you find bugs, but it takes a commitment on your part, and you're going to be a little frustrated using it at first because it's going to give you errors that you're like, how do I work around these errors? Okay. It will get better over time, but until it does, you just have to cope with the fact that it's an imperfect solution at the moment, but people are working on it. Briefly about doc strings. Doc strings are in Python. They're a good idea for code that you think you're going to share with other people. There's a whole bunch of recommended ways of doing doc strings. I use a program called PyDocStyle to just look at all my doc strings and complain at me. And mostly it says, you didn't actually have one, okay, which kind of forces me to write one, which is a good thing. There's a program called PyDoc, which will, you point it at one of your modules, it'll just print out all of your doc strings to show you what they look like. The sort of document that gives you all the rules on what doc strings should do is something called PEP 8. They really don't want you to have doc strings of length greater than 72 characters. And Guido von Rossum won't budge on this. He's really adamant. He thinks you should stick to 72 characters. I don't agree with him, but hey, he's retired benevolent dictator for life, so I can't argue with him. So I just go to the 72 characters. Okay. Now there's a whole bunch of different doc string styles out there. The one that's used to do all of the Python documentation is something called Sphinx. I find it to be hideously hard to read and write. I don't use it. There's a style that was produced by Google, which I find way more easier to read. I have the URL for it here, and it's there's an example of it there. So you always have the one-line summary at the beginning of your doc string, blank line, an optional multi-line description of the function, which gives you more description of what's going on. And then you have a list of arguments. The types are optional, but I always put them in because I like having types in my code. And then you have your returns, okay, and stuff. The blank lines, if they're not in the right places, PyDocStyle will just complain at you. It's just like Flake8 in that way. Okay, we're nearing the end here. There are a ton of Python debuggers out there. I use PUDB. It is a text mode, terminal mode debugger. It's not the greatest. It has one huge advantage, which is when I am debugging my ROS node on my robot from my terminal on my laptop terminal, which is not on my robot, it is possible to get the PUDB to display a screen up on my robot that I can use. Most of the debuggers out there just absolutely refuse to work remotely. So I view PUDB as a very reasonable remote debugger. I will also mention that if you're using ROS1, there is some wonderful magic in launch files where you can just sort of bolt in and make the right thing happen when you want to debug debug remotely. I have done this. I have forgotten how I did it, but it is possible. I believe ROS2 has ditched launch files and is using Python, but I'm not up to speed on ROS2. That's another talk. Okay. So anyhow, to install PUDB, you just install it. Okay. Another tool for debugging your code is tracing. And it took me a long time to find find out about tracing decorators. Decorators are, when you see that @ sign in front of and the name in front of it, what it basically says, hi, I want you to wrap this function in another function call. So I'm not going to go through this code in detail. You should read the URL describing it. I have edited this thing to be a little more Python 3-like and a little less Python 2-like, because I think the code was more Python 2 than Python 3. But basically what it does is it puts a wrapper around your function call, so I can print out the arguments on call and returns on return, which is like what you want it to do. And it's an extremely useful debugging tool, that alternative to running a debugger. Okay. So that's how you would call it. So you go @ tracing, and then the Fibonacci things. Nobody would ever write a Fibonacci generator like this, other than to show stupid recursion, which is what this is. Okay. Okay, testing. Let's see, testing is a good idea. How many people have heard of test-driven development? Oh yeah, good. It's a really good idea. Python has an enormous testing framework available to it. And it's basically called PyTest. And there, you can spend a lifetime learning how to use all the wonderful features in there. For starters, what you do is you put test files in your test directory, and it will run them, okay? Now what I do is I run PyTest with test coverage turned on, so I can figure out how good my test cases are, okay? And so what it will do is it will run all the test cases with test coverage turned on, and when it's all done, it outputs things called coverage files. And any of your lines that should have been executed but that were not will be in the coverage file starting with an exclamation point. So that's how I kind of figure out that I haven't really done it as good at test cases as I would like. So again, it's just a little trick of the trade. By the way, if you have debugging stuff that you really should never trigger anyhow, you go sharp pragma : no cover to make the test coverage stuff not flagged as unexecuted. Okay, you can wrap all this stuff up in a make file. I actually went to a talk by the guy who invented make, and he admitted that he really made a mistake by using this syntax. But it is what it is. I'm not going to try and explain it here. But basically, you can set things up so that basically, it's down here at the very end, it will run mypyflake8 and pydoc style, and then when it's all done, it'll remember that it did so. And then if you ever change the file, it'll run it again. Okay. So, whoops. I'm getting near the very end of the talk here, which is good because I've used up most of my hour. These days you should be using a decent programming environment to develop your code. I'm kind of old school. I'm still using Bash and Emacs. Most people are either using Eclipse. How many people here use Eclipse? Okay, not very many. How many people are using VS Code? A few more. Okay. VS Code has a better vibe for me right now, so you might want to think about giving it a look-see. It's cross-platform. It was originally developed by Microsoft, but Microsoft isn't the same old Microsoft it was 10, 15 years ago. So it's been open sourced. It's MIT licensed. And there's a huge community of people that are working on it. Eclipse is Java-based, it's gigantic. I believe IBM is leading the charge on keeping that going. So you should be thinking about using one of those. The reason why you want to use one of these is they tend to have better debuggers than just about anything else. It'll be way better debugger than PUDB. Okay. Lastly, everybody here probably has used Git. How many people have used Git? Yeah, okay, I'm not gonna waste time talking about Git. Comments, yeah, they're a good idea. None of us put enough comments in our code. We really should put more comments in our code. They really help out. Mostly because you're probably gonna be the person that debugs your code, so if you can't figure it out, nobody else is gonna help you. I tend to write pretty much all of my documentation in Markdown these days. How many people know about Markdown? Yeah, plenty. I used to be on the HTML committee, and when I saw Markdown, I said, oh gosh, I wish we had done this instead of HTML, but oh well, things happen. Then lastly, I mentioned this at the beginning of the talk, the MicroPython does exist, and I think we can actually use it for our lower level programming of our microcontrollers. I have it running on a Nucleo board. I was going to show it, but I'm out of time. It's kind of cool. Unfortunately, there's 3 forks of it now, at least. There may be more. There's the main fork, Adafruit and Adafork, and there's another fork called PyCopy. And the library which matters the most, which is the asynchronous I/O library, is in a constant state of flux. And that, if you're going to do low level of management of your resources in a microcontroller, you need to have it. So that's a piece of work to be done. I don't know, is any people here interested in working with MicroPython? Okay, I'll send out a message to the group, seeing if we can just sort of have a thread of discussion on MicroPython. Okay, and success stories, failure stories, because I know that Mark, you got running on an ESP32, right?
Yeah, it was almost painless. The binaries are there, and
yeah.
I haven't done much on another robot on that because I used a bunch of other OSs, but it seemed reasonable. Okay. So basically, Python 3 is pretty much here. So if you're going to be programming in Python, you're going to be programming in Python 3 because Python 3 is going away. You might as well use some of the new tools. And I'm interested in building some more interesting Python robots. So that's kind of where we're at. The URL is repeated here for your edification, and I'm open for questions. Yes?
So if you add type hints, does it do more than just static type checking, or is there any runtime benefit?
You can add a decorator that forces runtime type checking, but it is static. Okay, so you can actually do both. Okay, you can I want to warn you that decorators in MyPy don't work that well. So it may be that when you turn on runtime type checking with a decorator, it may have broken the static type checking of MyPy. Okay, so just a word. I haven't tried that yet. I'm pretty happy with the static. It works reasonably well. Yes, Mark?
You talked about async I/O, and then while you were doing that, you said it was better for the multi-thread support, and then you also said lets one thread, things to let a thread stop and let something else run. Does it have OS constructs like things to trigger another, a signal or a semaphore or that cue?
It has all sorts of things in it, but it's a moving target.
Oh.
Okay, and that's the problem. Okay, and each fork of MicroPython has a different set of features in there. So it's going to be a bit ugly digging through all of that, figuring out which fork to use, and which features to use and all that stuff.
AKA, stay on free arguments. Thank you very much.
Yeah, I know, but they have to program in C and all that stuff. Yeah.
Sure, Sadie.
So, next. No, further questions? Yes.
What is it you like about the MIT license?
Oh,
Repeat question, please.
yeah, he wanted to know what I liked about the MIT license. Some of you might know that I was a graduate student at MIT, okay? The initial paper on running the internet protocol on a PC was done by my group, and my name is actually on that paper. And that piece of code was originally released on the early version of the MIT license. So, that's, I kind of have a history with that. The license has changed over time. By the time it got to X11, it had morphed some, and it has morphed more since. Okay. So the history of the MIT license it's been a moving target, but kind of the original concept was cooked up to release the PCIP code stack for the IBM PC. So anyhow, that's just a
Is there a particular reason besides having graduated and written the original code?
Oh, it sort of covers what I view as the basis of, like, here's some code. Feel free to use it. Feel free to modify it, and don't come after me and sue me if it doesn't work for you. That's really all we ever wanted from a license. Okay, and then Richard Stallman decided he wanted to have a slightly more sticky thing where you had to share any changes you made. That's fine. He hung out at MIT too. So, further questions? Okay, I think we should go into social hours.